Hello dear students, welcome back to Power System class. We have completed third chapter in the previous class in which we have discussed about electrical power system structure and um, details of transmission and distribution sets. And today we are going to start the new chapter. Chapter is titled Power Factor and Power Factor Improvement of Load. Okay, and this is going to be very important chapter looking at from not only from exam point of view, but it is based for it is based thing uh, that you need to learn as an electrical engineer as well, because it contains the basics of electrical engineer which you will be using throughout your engineering and even throughout your careers if you are looking forward to make career in electrical engineering. Okay, so this is going to be very important lecture, very important session, so I request you all to be attentive. And without further ado, let's get started. So power factor and power factor improvement of load. So before going to the power factor, let's discuss something about power. Okay, so in your views, what is power? So how do we define power? We define power as, wait a minute, we define power as voltage. We define power as product of voltage in current, right? This is how we define power, right? E is equal to V into I, right? Then we have to um, go into a single phase or an AC system. We use different uh, approach, like um, don't only keep it till voltage and current. Why? Because when you go into the AC circuits, then you will be seeing there is a phase angle difference between the voltage and the current. Okay, so here you can see this line which is going here is my voltage line, and here is the current. So you see, magnitude wise both are almost equally same here. It can be anything. Okay, current can, it's better if current stays less. So let's, we will discuss why it is better when current stays less when once you get better of power factor. But let's say this is my voltage and this is my current. Okay, so there is some angle between these two, and that if we call that angle phi, then the cosine of that angle, the cosine of the angle between voltage and current vector will be called cos phi, and that cos phi is called power factor of my system. Okay, so that will be cos phi, cos phi. Okay, so this cos phi, it is called power factor, right? And as you can see here, that voltage is leading the current. See, voltage is ahead of current here. How do you define if it is ahead or behind? So if we go clockwise, okay, if we go clockwise means यहाँ पे 12 है, यहाँ पे 3 है, यहाँ पे 6 है और यहाँ पे 9 है. सो 12 से 3 तक जाते हुए, मतलब क्लॉकवाइज जाते हुए, जो कंपोनेंट पहले आएगा that component is leading. So think of this as a think of this as a two think of this as a two of the, so think of this as two of the clock hands, V and I, and V पहले आ रहा है, so V is leading, seeing from clockwise direction. Okay, तो V पहले आ रहा है, so V is leading current by phi angle. We say it V is leading the current by phi angle, which means my current is lagging, और जो भी एंटिटी लैग करती है, मतलब जो करंट जो कुछ भी करता है, अगर करंट जो अगर लैग कर रहा है तो वी कॉल इट लैगिंग पावर फैक्टर। अगर करंट मेरा लीड कर रहा है तो वी कॉल दैट लीडिंग पावर फैक्टर। जो करंट लीड कैसे करेगा, लेट्स टेक अ सिनेरियो, लेट्स से this is my voltage, okay, if this is my voltage and then this is my current, okay, if current comes before the voltage, so if current comes before the voltage, see here what is happening, this is my current, so ये है मेरा करंट, this is the voltage, okay, so क्या हो रहा है, करंट जो है वो वोल्टेज से आगे है, so which means this is leading power factor, okay, ये हो गया मेरा, let's write here, ये है मेरा lagging power factor, और ये जो है ये हो गया मेरा लीडिंग पावर फैक्टर, ओके। नाउ व्हाट वी विल डू, पहले तो लीडिंग और लैगिंग होता किसकी वजह से, तो लीडिंग पावर फैक्टर या फिर लैगिंग पावर फैक्टर, दोनों के ये जो रिस्पॉन्सिबल होते हैं पैरामीटर्स वो है रिएक्टिव और कैपेसिटिव पैरामीटर्स, ओके। जब रिएक्टिव पैरामीटर आता है तो क्या होता है, मेरा जो पावर फैक्टर वो लैग कर जाता है, और जब मतलब जब इंडक्टिव एलिमेंट आता है, इंडक्टर इन्वॉल्व होता है, ठीक है, तब मेरा पावर फैक्टर लैग कर जाता है, और जब कैपेसिटिव एलिमेंट आता है तब क्या होता है, पावर फैक्टर मेरा लीड कर जाता है। बट नॉर्मली ऑलवेज कीप इन माइंड कि पावर फैक्टर जो नॉर्मली होता है हमेशा लैगिंग ही होता है। वाई? बिकॉज वी आर मोस्टली हैविंग इंडक्टिव लोड्स अराउंड अस, सो पावर फैक्टर जो है वो मोस्ट ऑफ द केसेस में लैगिंग करता है, लैग करता है, ओके। Now third case, like what if my voltage and current are perfectly in sync, like here is the voltage and same ways I have current, okay. Okay, so here voltage and current are perfectly in sync, right? वोल्टेज और करंट क्या हो गया, परफेक्टली इन सिंक हो गए। मतलब ये जो मेरा वोल्टेज है और करंट है वो एक दूसरे के साथ में ही मूव कर रहे हैं, फेज एंगल का कोई डिफरेंस उसके बीच में है नहीं। सो दैट इज़ द केस ऑफ यूनिटी पावर फैक्टर। और उसमें क्या होता है, वोल्टेज करंट दोनों ही एक दूसरे से लैग या लीड नहीं कर रहे एक दूसरे को, वो साथ में चल रहे हैं, वो हो गया यूनिटी पावर फैक्टर। मतलब उस टाइम पे जब ये केस होता है तब कॉस फाई का वैल्यू क्या हो जाता है, 1, जो आइडियल वैल्यू है पावर फैक्टर के लिए, ओके। एंड ये सिचुएशन कब क्रिएट होती है, जब मेरा जो लोड जो है वो होता है रेजिस्टिव लोड। लोड क्या होता है, कंप्लीटली रेजिस्टिव। मतलब जब लोड के अंदर कोई भी लैगिंग या लीडिंग एलिमेंट नहीं होता, तो ये हो गया resistive load. Now one more thing I want you all to notice. I have a question कि पावर फैक्टर का वैल्यू, सोचो कि यूनिटी जो होता है तो उसका वैल्यू 1 हो गया, ठीक है। सो पावर फैक्टर का जो वैल्यू है वो 1 से ज़्यादा बढ़ सकता है या नहीं बढ़ सकता। आई वॉन्ट यू ऑल टू थिंक अबाउट इट। ओके, और क्या पावर फैक्टर का वैल्यू नेगेटिव हो सकता है या नहीं हो सकता। एंड फॉर दैट आई वॉन्ट टू थिंक कि जो कॉस फंक्शन है उसका रेंज कितना होता है। आई वॉन्ट यू टू थिंक व्हाट इज द रेंज ऑफ माई कॉस फंक्शन, कोसाइन फंक्शन। ओके, एंड I'm giving you time to think about it, and I want you all to mention your answers in the comment section. In the next lecture I will reveal the correct answer and we will discuss it in detail. Okay, so think about it. The answer is very simple. It is hidden in the range of cos function. Okay, so now that was our three types of power factors. लीडिंग हो गया, लैगिंग हो गया और यूनिटी हो गया। आइडियल जो होता है वो यूनिटी होता है, मतलब आइडियली पावर फैक्टर का वैल्यू क्या होना चाहिए, 1 होना चाहिए। ओके, नाउ जो तीन पैरामीटर आपको मैंने बताया कि जो इम्पोर्टेंट होते हैं, रेजिस्टेंस, कैपेसिटेंस और इंडक्टेंस, जो तीनों ही इम्पोर्टेंट रोल प्ले करते हैं, ठीक है। नाउ कमिंग टू द परपेंडिकुलर कंपोनेंट्स। ये जो मेरा करंट है उसके मैं दो कंपोनेंट्स सोच सकता हूँ, ठीक है। एक कंपोनेंट जो होगा वो जो मेरा वोल्टेज है, थिंक इफ माई वोल्टेज इज परपेंडिकुलर टू एक्स एक्सिस। ओके, सो एक जो मेरा करंट का कंपोनेंट होगा इट विल ऑल्सो बी परपेंडिकुलर टू एक्स एक्सिस, विच मीन्स इट विल बी परपेंडिकुलर टू वी। it will lie on the same plane as v. Okay, and then there will be another component which will be sorry, yeah, one will be perpendicular, sorry, when it will be perpendicular it will be straight up, and then other one will be parallel which will lie on the same plane as v. Okay, so if I had to draw them, how will we draw them? We will draw them something like this. This is the component. Which component it will be? It will be the perpendicular one, and this one which is parallel to v, that will be another component. Okay, now the component which is perpendicular to v, which means this component. Okay, this component is called vi sin phi. Okay, this component is called vi sin phi. If you just take it, if you just create a copy of it and you can just move it around, then you will know. See, this becomes a triangle. Can you see? This becomes a triangle, and here is an angle phi. So when you find it, this will be vi sin phi. Okay, vi sin phi, and this will be vi cos phi. This line will be vi cos phi. Okay, and based on the same thing, I'm here to discuss about the power factor triangle. Okay, let's see power factor triangle. What is it? So now coming to the power factor triangle, here what I've drawn, it's the same thing. This line which is going horizontally, this is my vector of voltage v. This is this line, this is my line I. which is nothing but current. Okay, now this line which I have drawn perpendicular to V, as I was saying, it is nothing but the sine component of my I. Okay, and this line is nothing but cosine component of my I. See, uh, this if I have to take out two components of this vector, what it will be? I sine phi and I cos phi. So I drew this, which is I sine phi, and I took that vector over here, and here we have I cos phi. Now what is our ultimate purpose? We want power, right? We want to find the power. So we will multiply that I with V, which makes this component Vi cos phi and this component Vi sin phi. Okay. Now this component, which we just call Vi cos phi, it represents the true power, or in other words, you call active power. Let's write it over here. Active power. So this is active power, and active power is the power which we normally use when we do any most of the operations, right? The power we use is active power, and the unit we use for active power is watt, right? Watt or kilowatt or megawatt, but basic unit is watt. Then this component Vi sin phi component, this component represents something called reactive power. Right, this is reactive power. And what does reactive power do? So reactive power is power that we normally don't consume, but it is important in the transmission lines and many other purposes. Okay, which we will discuss for as we move further in the chapter. So this is my reactive power. And what is the unit of reactive power? It is we call it var. Okay, we call it var. You can call it kilovar or megavar, but we now go to megavar, but it is basically var. Okay, and then if you want to find the net power or apparent power, then what do? We take what do we do? We take vector sum of these two components, right? Vi cos phi, Vi sin phi, and we get this, and that is called, what do we call it? Apparent power. Okay, so let's write it also. So this is nothing but apparent power. So vector addition of these two, and if you just want to find the magnitude, you can just do under root of v square plus I square. You will find magnitude. Not I mean, under we can just do like under root of p square plus q square. P represents active power and q represent reactive power here, and s represent my apparent power. So s equal to under root of p square plus q square. That makes my apparent power. And what is the unit of apparent power? Apparent power's unit is VA. Okay, and we might go into kVA, MVA. Okay, and where do we use it? If any of you remember, in transformer rating, we have rating of the transformer in VAs, kVA. Okay, so we use it over there. Now this was your basics of power factor. Now there are so many more things we need to discuss about it, like uh, if you take this only this triangle only in consideration, and there is a phi over here. Let me try it. This will be my phi. This will be my phi. So here will be the value of my phi. Can you see? This will be the phi. And uh, based on this, if you want to find the power factor, which is, what is it, cos phi, how do you find it? Based on this triangle, you can just simply go in the division of active power divided by apparent power, and you will be find the cosine, right? So this way, this is the another way you can find the power factor. Now there are few little things which I will discuss in this lecture, which are important about the power factor, like uh, रिएक्टिव पावर जो हो गया, रिएक्टिव पावर का जो कंपोनेंट है, दिस कंपोनेंट, सी यू आर सीइंग दिस कंपोनेंट साइन साइन फाइव वाला, इट शुड बी एज स्मॉल एज पॉसिबल. वाई? बिकॉज जितना ये कंपोनेंट छोटा होगा, उतना ही आपका जो पावर फैक्टर है वो ज़्यादा बढ़ेगा. बिकॉज ये कंपोनेंट अगर लेंथ में छोटा रहेगा, विच मीन्स ये जो फाई है, जो आपका एंगल है, इट विल बी लेस. ओके. एंड जितना वो एंगल कम होएगा, उतना जो कॉस फाई का वैल्यू है वो ज़्यादा होगा, राइट? बिकॉज कॉस कॉस का आपको पता है कि कॉस 90 का वैल्यू 1 होता है, और कॉस 0 का वैल्यू क्या होता है? सॉरी, कॉस 90 का वैल्यू 0 होता है, और कॉस 0 का वैल्यू क्या होता है? 1, राइट? सो जितना जितना वैल्यू कम रहेगा, उतना ही बेटर आपका पावर फैक्टर मिलेगा, और जितना बेटर पावर फैक्टर मिलेगा, उतना ही ज़्यादा एफिशिएंट आपका मशीन होगा. सो इट शुड बी लाइक दैट. देन देयर इज अनदर थिंग इज़ कि जितना आपका पावर फैक्टर जो है वो बेटर रहेगा, उतना ही जो करंट होगा, आपके लाइन में जो करंट यूज़ होगा वो उतना ही कम होगा. और करंट कम होगा तो क्या होगा? जो आपके पावर लॉसेस होते हैं, मतलब I2R लॉसेस जो होते हैं, वो लॉसेस जो है वो बहुत कम होंगे. ओके. सो ये पावर लॉस जो है उसको हम क्या कर सकते हैं, उसको हम लोग ऑप्टिमाइज कर सकते हैं विद द हेल्प ऑफ बेटर पावर फैक्टर. और पावर फैक्टर जो है वो आपका नॉर्मली 0.8 से 0.85 अराउंड होता है. एंड देर इज़ वन मोर थिंग अबाउट पावर फैक्टर की, जो इंडस्ट्रीज़ होती है उसमें हमेशा बहुत ही स्ट्रिक्टली पावर फैक्टर का वैल्यू जो है उसको मॉनिटर किया जाता है कि उसका वैल्यू अगर 0.8 से ज़्यादा ही होना चाहिए. अगर वो वैल्यू अगर कम जाता है तो they have to pay some fine to the government, because not managing the power factor thoroughly. So they even have to pay fine to the government because not managing power factor. So we will keep this lecture till here today. In the next lecture we will be discussing about the advantages and disadvantages of power factor. I mean disadvantages of low power factor and advantages of high power factor, and how we can improve our power factor. Okay. And what causes the low power factor. So we will be discussing this. Don't worry, you will hear the term power factor a lot in electrical engineering, and this whole chapter, and there is many more, so many things which are about to come, and there will be a lot of importance we will be giving if you are working with AC system to the power factor. So we will keep this lecture till here, and in the next class I will be seeing you. Till then, take care everyone. Thank you for listening.